Going faster makes traveling more exciting. And to get up to a faster speed, we must get our vehicles and bicycles to accelerate. Hi, in this lesson, we're going to talk about accelerated motion. So uniform motion is an object that's traveling at a constant rate in only one direction, like if you're driving on cruise control. Most objects in motion will encounter forces such as friction, which will cause them to slow down, and accelerating forces such as a motor, which will cause them to speed up. These objects are then experiencing non-uniform motion or accelerated motion. The formula for acceleration is acceleration equals velocity divided by a change in time. And again, we have to use velocity, not speed. So we're going to have that vector velocity. So we must use the vector velocity of acceleration to find the vector velocity, or we need to use the vector velocity to find the vector acceleration. So we will take the final velocity, subtract the initial velocity, and divide it by the change in time. Now, because velocity is a vector, it can change in two ways. It can change in magnitude, quantity, so it can become faster or slower, or it can change in direction, left or right. So speeding up would be a positive change. Going north, east, or up, or right would be a positive change. And we would use the symbol positive or write the letter of direction. Now if we're speeding up in a negative direction, this is going to be negative acceleration. So if we're speeding up going in reverse down the highway, this is negative acceleration. Now, if we're slowing down while traveling up, right, north, or east, this would be, again, negative acceleration. So if we're traveling forward but decreasing our velocity. Now, if we're slowing down while traveling in a reverse direction, so if we're slowing down while going down, slowing down while traveling left, this would then be positive acceleration because we have two negative vectors. So there are three pieces of information that are given by the acceleration of an object. One is the positive or negative sign. It tells us are we having positive acceleration or negative acceleration. The magnitude of acceleration tells us the quantity of acceleration, the change in the velocity per second. And then the direction indicates the change in the trend of velocity. So because acceleration is a vector, direction influences the overall positive or negative nature of this value. So we have the positive or negative sign. Are we speeding up or slowing down? The magnitude, by how much, and then the direction of travel. So what is the acceleration? When a traffic light turns from red to green, a car accelerates from rest to a speed of 12 meters per second in 10 seconds. So we have our information that we know. So our initial velocity was 0 meters per second. Our final velocity is 12 meters per second, and our time is 10 seconds. So all our units are the same. So here's our formula for acceleration, and this is in your data booklet. Now we're putting in our data, so 12 meters per second final velocity minus 0 meters per second our initial velocity divided by 10 seconds gives us an acceleration of 1.2 meters per second and positive 1.2 meters per second. So when we look at negative acceleration, it takes 10 seconds for a car to stop that's been traveling at 15 meters per second. What's the acceleration of the car? So again, we take our data. So our initial velocity is 15 meters per second. Our final velocity is 0 meters per second. And our time is 10 meters per second. So putting that into our formula that you find in your data booklet, 0 meters per second, subtract 15, divided by 10 seconds gives us a total acceleration of negative 1.5 meters per second squared. We can also use this formula to find our final velocity. So when we were given information, our initial velocity is 0 meters per second. Our acceleration is negative 9.81 meters per second down. And this is going to be an acceleration downwards towards the Earth, and the time is 15 seconds. So 9.81 meters per second squared is the acceleration of gravity, and you'll find that in your data booklet as well. So we've rearranged our formula to be final velocity is equal to acceleration multiplied by time plus our initial velocity. So that's just a rearrangement of the acceleration formula from your data booklet. So putting all our information in, negative 9.81 meters per second squared multiplied by 15 seconds plus 0 meters per second squared because we didn't have any initial velocity. And we have a final velocity of negative 147 meters per second downwards. Okay. Sometimes we have questions where we don't have an initial or final velocity that is 0. And we have numbers given to us in kilometers per hour. So we're going to convert our velocity into meters per second. So again, to convert kilometers per hour to meters per second, we're going to divide by 3.6. So 60 kilometers an hour is 16.67 meters per second. 100 kilometers per hour is 27.78 meters per second. So we can put that information into our formula, and we will end up with the acceleration of the car from 60 to 100 kilometers per hour in 10 seconds was an average acceleration of 1.1 meters per second squared. And again, that's a positive number. Okay, our last example here is going to be to find the initial velocity. So a rock is thrown off a cliff and reaches a final velocity of 18 meters per second after falling for 10 seconds. What velocity was the rock initially thrown downwards? So we're going to put the information that we know onto our work page. Then we're going to rearrange our formula to find the initial velocity. So we're going to multiply both sides by our change in time, and then we're going to add final velocity to both sides of the equation, and then divide or multiply both sides of the equation by a -1. So we have initial velocity equals negative acceleration multiplied by time plus final velocity. So putting our information in, and again, we want to have those directions and negative signs as well for our velocities and acceleration. We end up with negative 20 meters per second was our initial velocity of that rock being thrown downwards. So the trickiest part to these questions is making sure you have your formula rearranged properly. Now, this is something that you can practice, and you can always check your answer afterwards if you're unsure by using the initial formula from your data booklet and putting in the value that you got as your solution to see if the acceleration, for example, in our acceleration questions is what was given to you in the question. I hope you enjoyed today's lesson. Take care.